Hi everyone, this is Mr. Murray and we are going to learn about Venn diagrams today, and more specifically how to calculate probabilities based on a Venn diagram. Okay, so let's start with the beginning. How can we use Venn diagrams and the rules of probability and sets and sample spaces to calculate probability? Well, let's take a look. Here are some very important definitions. We have union, intersection, complement, and the empty set. So starting with the beginning, let's say we are rolling a die, and the die has numbers 1 through 6. So we have 1, 2, 3, 4, 5, 6. Now let's define two events. Event S will be if you roll a prime number. Now recall, prime numbers, I'll write it down here in case you forgot. Prime numbers are greater than 1, and they're only divisible by 1 and themselves. Let's write that down. By 1 and themselves. So what's prime? If you have a die, and you roll it, the possible prime numbers, therefore, if it can only be divisible by 1 and itself, that would be 2, 3, and 5. Okay, and then event B will be rolling an even number. Okay, so even, down here again, even numbers could be 2, 4, and 6 if you're looking at a die. So using this definition of union, it's combining both. It's the union, like when you're married, the union of two people. So you're taking something from both sides. And they use the word or a lot, or this symbol U right here. So if you want to know the probability of S union B, so that would be 2, 3, 5. That's my set S. And if I union the set B, those are my evens, right? That would be 2, 4, and 6. So what we want to do is just put them together. But let's not count the dupes. So that would be now a set of all possible numbers that would make us happy, 2, 3, 4, 5, 6. And that's a total of 1, 2, 3, 4, 5 numbers out of 6 possible. Now let's talk intersection. S intersect B. What's this probability? Okay, so going back to set S. Set S has 2, 3, 5. If we want to intersect it with set B, which we agree has 2, 4, 6, where do you see dupes? Where are the duplicates happening? That's what an intersection would be. So I see that the number 2 is happening in both of them. That's where there's overlap. It's like a repeat. So that's one number out of our total sample size of 6. Let's say the probability of some event is 70% or 0.7. Well, you know that the maximum probability you can ever have is 100%. Remember, you can't say I'm 110% sure like some people say all the time. So if the max is 100 and you've got this probability of an event happening is 70%, then the probability that it doesn't happen, which is an A in this example with that line on top, that would be 100% minus the probability of it happening. So as you can see, quite simply, it would just be 30%. So that's what complement is. And they use these words not or nor in the word problems. And visually speaking, they can be the set with a line over the top, or the set letter with like an exponent of C, which stands for complement. So what are we asking here? What's the probability of not rolling a prime or even number? So the probability of not prime or even. So I think we've already done prime or even. Let me just take a look. Yeah, we did it right here with number 1. So we can say that it's equal to 1 minus 5/6 or 1/6. It's that easy. And the last idea is this thing called empty set that I'd like to talk to you about. You might hear the word null or empty, but really important, it's this symbol like this. And it's really just the impossible, or something not matching any criteria whatsoever. So if you think of a die and it has the numbers 1 through 6, what would be the probability of rolling a 0? Well, that's nothing. That is actually impossible because what are the set of 0 numbers? Well, that would be nothing. It's empty. Divided by how many numbers do we have altogether? 6. So there's nobody home. This is the symbol we use to represent nothing when you're talking about sets. Now let's take a look at Venn diagrams. Okay, so to do this, let me just number each one of these Venn diagrams with some of the data values we have. We had 1 through 6. So here was number 1. And then 2 was both prime and even. Our other prime numbers were 3 and 5. Even numbers were 4 and 6. Let me just repeat that process for these other ones before we begin.
I want to address my wart, the one on my knee. You see, I want to just shear it off and then keep it. Maybe tuck it in a tray or a decorative box, and no one could find it. It'd be a secret, hidden away like my frisbee and my Grover mask. What?
There was like the wart man.
Was he wearing a hat?
Okay, so how do you shade number 1? Number 1 said, give me everybody who is prime or even. So that would look like this. We'll take a highlighter of everyone who is prime. That's all these guys right here. And everyone who's even. Okay, that's all these guys. So it's those numbers. 1, 2, 3, 4, 5. 5 out of a total number of 6. That's how we got that answer. So that's a visual representation of question number 1, the union question, but using Venn diagrams, which is what I need you to know how to do. Let's go over to question 2. Question 2 was the intersection. So for an intersection question of who is even and prime, well, that would be where the overlap is, right? So here's my even numbers, here's my prime numbers, but where do they overlap? Where are they both? That's right there. And that's a total of 1 out of 6. Question number 3, the complement. Who is not in both? So let's take a look at that. So I'll take my highlighter, yellow. Here's everyone who's even. Here's everyone who's prime. Where am I not? That guy. So let me just erase that because I think it's a little misleading. I will do this. Okay. It's everybody who's not over there. Let me put back my number 1, which I just magically deleted. Sorry about that. That guy right there. So 3 and 5, you're still here. 2 is over there. 4 and 6. 1 is my answer. And of course, the probability, therefore, is 1 over 6, or the decimal that that fraction represents. Let me just write that down. Okay. And last but not least, what's the probability of a 0? Well, you're looking at it. Nothing. I'm not going to color in anything because there's no 0 there to be had. Okay, this is just for practice. I thought this was really cool. I found it on the web. It's just classification of animals using Venn diagrams, and it's a little more interesting because it's not just 2 circles. there's 4 circles here and a couple of people who are on the outside. So let's see if we can't figure this out. What's the probability that if we just randomly picked an animal, that it would be an animal that can swim or breathe air? So if you can swim or you can breathe air, you count. So let's use some shading and see what happens. So where are you if you can swim? All right, that's the blue one. So let's do a little blue right here. So that's everybody inside this circle. And I mean everybody. Even inside that red circle with the fins, all that business, right? It's everyone inside here. Okay. Now let's add on to that, because this is an or question. Or who can breathe air? So that's green. So I'll do a little green over here. And we're going to include all of you guys. Cool. It's everyone in those 2 colored regions. So I did a little checking before I did this, and it turns out there are 17 total, right? So n equals 17. That's the total amount of animals in this picture. Let's count up the ones that match. So I know my total is 17. My desired is, let's see, earthworms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 17. Now I've been using fractions. I have been using fractions this whole time. So let me just turn these into decimals, because after all, the probability is a decimal and it's always less than 1. So it's 0.82. There's an 82% chance that if you just randomly pick an animal, it will be someone who can swim or can breathe air. Okay, so sometimes Venn diagrams use probabilities. They don't just use the raw numbers. Okay, so let's take a look at one of those examples. When a fish is selected at random from a tank, the probability that it has a green tail is 0.64, or 64%. So I'm just going to put an arrow over here and say that you're 64%. The red fin would be 25%. And the probability that they are both green-tailed and red-finned is 0.19. Now, if 19% is the overlap and 25% is all the reds, then this area right here has to add up to 25%. So this is going to be 0.25 minus 0.19, which is 0.06. Okay, so that's in that section of the Venn diagram. How about over here on the left? If this is all the green tails and 64% are there, then the total that are just green with no overlap would be 64% minus the 19 that are shared by red, and that would give us a total of 0.45. So now we can easily find probabilities. For example, the fish has red fins but does not have a green tail. Okay, so that's going to be the 0.06, because that's where they have red fins, but we don't want the overlap where the green tails are. So that's simply 0.06. The fish has a green tail, but not red fins. That's 4.5. The fish has neither green nor red fins. Now that's crazy. How do we calculate that? How do we say how much is in this area? Right? Because that's everyone in the world who does not belong in these circles. Well, you have to be very comfortable with this fact, that everybody would be 100% of the people, minus, let's add up how much we have. So we have 45%. Those are the ones with just green. And we have 6%. Those are the ones with just red. So if we take 100% of the population and we subtract those 2 groups, we will have the total number of fish that have neither green tails nor red fins. So what does that equal? 1 minus 0.51, which is 0.49, or 49%. So the last thing I'd like to do with you is just complete a table based on this, because the next video that you watch will have tables like these. They're called two-way tables. Let's just take a look at our probabilities and fill them in. So the intersection of these two cells right here, green tails, red fins. Where do we see that? Green tails over on the left, red fins on the right. Where are they matching? Where do they intersect? 0.19. How about red fins but not a green tail? Okay, here's everyone with the red fins. But let's get rid of the overlap because that's where they also have green tails. So just red fins would be this little 3/4 of a moon here, 0.06. Adding them up, you get 0.25. So, how about the green tail, but without the red fins? Okay, so that's the 3/4 of a moon over here on the left, which we determined earlier was 0.45. Well, first let's total this. So down here we get 64, which is correct because we had 64% with green tails. Nice. And we had 25% with red fins. Perfect. The not green tail, not red fins, number 3, if you notice, I took 100% and I subtracted the 0.45 from here and the 0.06 from here. I ended up with 0.49. I forgot the 0.19, that was the overlap. So let's do that again. And that will give me a total of 0.3. So we put that right here. We add this down and we get 0.36. We add this over, we get 0.75. And if you look this way and this way, our total is 100. So this is a pretty cool way to go from a Venn diagram to a two-way table where we can represent the probabilities in a different format. And this is the video that you'll see tomorrow where we start looking at tables like this and asking ourselves the same exact questions that we did using the diagram. I hope you enjoyed the video. Have a great night, and we will see you tomorrow.